Hello and welcome back to Incremental Factory. We're going to cover the setup of a nuclear power plant today for your factory. It's just going to cover the basics of the system to get you up and running. I will also be releasing a video of a more complex setup of a power plant capable of producing 1.5 million energy. So make sure to check out that video as well. Okay, let's add a production parcel. Inside this production parcel we need a minimum of two things. We need a reactor core and we need a turbine. The turbine does not require anything to operate it. It does require some materials to build, but it just does not input anything or output anything. The reactor core requires reactor fuel, and it outputs used fuel and energy. So you can see it creates 727 energy. We can add a second reactor core. It now provides 955 energy. That is times 2, so each reactor core produces 955 energy, so it would be roughly 1900 energy created by these two reactors. You can also add a second turbine which creates more power, 1136. So now we're at 2300 power. The other thing you're going to want to add to this is a heat exchanger. They are not required, but they do amplify the power production significantly. So that is the heat exchanger added. You can see now that we now create 3,209 energy. You can add a second heat exchanger and that creates 4,720 energy. So you can play around with these numbers to get a setup you're happy with. Just keep in mind the inputs and outputs do not climb in a linear fashion. The more reactor cores you have, the increasingly amount of reactor fuel you need. Okay, so this setup requires reactor fuel to be input as well as coolant, and it outputs used coolant and used fuel. So we need a total of 4 connections on this parcel, which means we can have up to 26 building slots. Once you go above 26 building slots, you lose that 4th connection. So you are going to want to limit these combination of buildings to 26. You can see it requires coolant here, reactor fuel here. It outputs used coolant and used fuel. Used coolant we can just drag up here, put it in a node, and grab this over here, put it in a production parcel, and we can have a coolant recycler here. Now this system creates used coolant, 4 used coolant, so we will need to process 4 used coolant over here. This can only process 0.15 used coolant, so we will need a lot of them. Let's just max this out. That processes 4.8 used coolant, so that'll be good enough. And that basically just takes the used coolant and turns it back into coolant. So we can output this to a node. And then we're actually going to drag this and put it back into the system. So we're going to grab another node over here and output this into the system. So it'll basically recycle our coolant. This is a closed loop system, so this 4 used coolant actually creates 80 coolant, which is what's required for the reactor core here, or for the heat exchanger, 80 coolant. So once you will need to create 80 coolant to jumpstart the system and input it into the system somewhere, but once it's in there you will not have to produce coolant, it'll just continue to flow through the system. We can take our used fuel down here and do something similar. This is a little bit more complicated though. We will take this used fuel into another production parcel, and this will make a fuel recycler. The fuel recycler takes in used fuel and turns it into coolant. We are not going to want to combine these 2 coolants. This creates just enough coolant that the heat exchanger needs to cool off the reactor. So we'll leave these as 2 separate systems. This one will just operate by itself. Notably, the heat exchanger does require coolant to operate to create the extra power. If for some reason you're short on coolant, it will not operate at 100% efficiency. Used fuel down here will be turned into coolant. That coolant then will be used into another production parcel, the reactor fuel plant. This is how we will create reactor fuel for the reactors. It requires coolant and refined thorium. So refined thorium is going to be used up. It is not a closed loop system. The coolant in this case will be a closed loop system. Again, the used fuel will create just enough coolant to be able to create the reactor fuel that we need to power the system. Let's grab the extraction parcel down here. We need some thorium production. So we'll put in some thorium miners here. I am just going to max this out for now. This is going to be way overkill. We're not going to worry about ratios right now. I will worry about that in my next setup. So this is thorium. This will go into I do a node just because everything goes into a node. Put that into a production parcel that is creating refined thorium. This is our reactor core. We need 1.07 reactor fuel per reactor, so that means we need 2.14 reactor fuel. So 2.14 reactor fuel, this is basically 3 of these. They create 1 reactor fuel per building. So that's going to require, I'm not going to do the exact calculations, but it's basically going to be a little over 50 coolant and, you know, roughly 5 thorium, we'll say. So we're going to want 5 of these. That'll create thorium. We'll take that into the reactor plant here, reactor fuel plant, and then the coolant, again, the coolant will need to be jump started in the system. Once you put enough coolant in, it will not be required to be added back into the system. So super nice. The reactor fuel can come out into a node, and again, this will be put back into the system. Just drag this down to here. Is thorium being created and used up here. This coolant, it needs to be injected into the system. So we need to get a setup for coolant going. Let's put down a production parcel. Just requires a coolant plant. A coolant plant requires graphene and petroleum barrels. So this is 2 extraction parcels, one making oil, one making graphite. The oil can come into a node, just force of habit. This will go into a production parcel. This production parcel will be making oil refinery, which will be petroleum barrels. Petroleum barrels will go into the coolant plant. And then we need graphene. This will go into a node. Graphite will go into a node. Go into a production parcel. This is a graphene lab. Graphene lab requires coal ash, so we're going to need some coal. Put another extraction parcel up here with some coal in it. So this needs to go into a coal combustor to make coal ash. And coal ash needs to come into the system down here. So we have coal being extracted into a coal combustor, feeding the graphene. And then we have graphite being produced as well into the graphene, which produces the graphene that we need. And that makes coolant. So we're producing coolant here. So what we're going to do here is we're going to add a second production parcel. We're going to put this as a coolant plant as well. And then we will connect these up. We will basically just stop this, like we will stop it now. We'll wait, that'll produce some coolant, but it's going to be more than enough. Put it into the system here and take it out. So that is fed the system already. You can see it circulating through the system here now. You can see there's no coolant in there, it's just constantly flowing through the system. I have this parcel right here which has some coolant in it. 230 coolant. We're going to input this into the system here. Let that transfer and then just close it out. So now we have coolant in the system. We do not need to create any more coolant. It is self-maintained. Now you can see that this is creating a little bit of power. Right now that we have coolant in the system, you can click on the reactor core here, and you can see it is working. It's producing some power here. Now you can tell it's not 100%. It's at like roughly 10%. This reactor core, this green bar would be all the way up here if it was 100%, and this number would be, this number should be almost 9,000, a little over 9,000, and we're only at 300 to 600. So you can tell it's not operating correctly. So we need to work on that. Looks like it requires 160 coolant, providing a portion of that. So let's put some more coolant into the system. Let's grab this one. I think this one has some coolant in it. It has 450 coolant. We can probably dump that whole thing into the system. Now you can see we have a slight backup, so there's enough coolant in the system right now. So now we need reactor fuel, because reactor fuel is not showing up. We have 0 reactor fuel, so we're not producing enough reactor fuel. Let's check the reactor here. We are still not at full power here, so something is wrong. We've checked the coolant line. Let's check the fuel line. We are creating 0.32 used fuel recycler. We are not using up the 0.32. We are only using a 0.03. So we need to increase this to, I think, 12, maybe 13. 13.33. So now we're creating enough. We're using up the used fuel to make coolant, which should cycle through the system. So now if we click on the used fuel, we can see we're at 100%. We are making 9,456 energy. And you can see that it's basically flowing through the system. This is just above this number here, 2.14. So we have enough in supply waiting to be refilled. And same here, we have 300 coolant waiting to be filled. You don't want to overload the system because then it'll get stuck. But this is just enough in the system to keep it. And you can see these are at 0. It's being used up and reprocessed into the ingredients it needs. So that is the basics of nuclear power plant. You can see how you can reuse the systems. I recommend keeping the coolant separate that is created from the fuel, that is the used fuel and the used coolant. Keep them separate because the math does work out that the used coolant can produce exactly enough coolant to refuel the heat exchangers, and the used fuel can create just enough coolant to supply the reactor fuel plant. So this is just a basic setup to show you how it works. These things that can actually become quite powerful. To give you an example, I'm going to try to do something a little ridiculous in my next build. I'm going to try to do 18 reactor cores, 5 heat exchangers, and 3 turbines. That gives you 85,000 energy per reactor core. So that is 18 times 85,000, which is a little over 1.5 million. So that's going to be a crazy setup. It's going to require a ton of supporting buildings to be able to produce that kind of power. But it should be a fun little project to do. A lot of people say that 9 reactor cores is the way to go because that basically requires a little over 1,200 coolant to operate, which is just under the cap of 1,250 that we are limited to. Each one of these lines here, the maximum it can transfer is 1,250. So that is the basic setup for nuclear power. Get you up and running. You can play with the numbers as much as you want. I am going to do my next video now, which will be producing a power plant of 1.5 million energy. So I hope to see you there. Thanks for watching. We'll see you next time.